Okay, so let's start with our session today. We still are on the topic of measurements, still reviewing the part of the graph, the relationship, the gradient, the area, interpolation, extrapolation. So we're still doing the paper 3 question. So we're gonna continue doing that until we are confident enough to answer it without any losing marks. So that is our goal. Because paper 3 is very easy to score and it's kind of like a life buoy for our marks for the physics. So if you score full mark for paper 3, guarantee you already can obtain C plus above or B minus even, B or B minus even if you can score paper 1 as well. So make sure that this is your chance to grab A, if not B or B plus in physics. So it's not that hard. It just need you to pay attention to details and also be careful in every answer that you write. So let's continue. Today I picked the question from SPMRSM 2018. Okay, a student carries out an experiment to investigate the relationship between the collector current IC and the base current IB of the transistor. So basically this is a topic from Form 5 that you don't learn yet, but it doesn't matter because we need to analyze the graph only. Doesn't requires you to understand the concept. It's just still using the amperes, the unit that you already encountered before, and doesn't introduce you something new other than the terms of collector current and base current. Basically, it's just current. So a transistor here acts as a amplifier. You will learn that later in your Form 5. Basically, it will amplify current. It will make the current become bigger. Okay, the results of this experiment is shown in the graph of IC against IB in diagram 2.1 on page 9. So let's check that first because that is the first step. You have to look at the graph. So again, we have the title graph IC against IB. So IC is the responding variable. IB is the manipulated variable. So based on the title itself, we already extracted the information about the variable. So here is the responding variables. The unit is ampere, but it has a multiplier here, 10 to the power of negative 3. So make sure that you pay attention to that. And the x-axis is IB over here, MV. It also has a multiplier, 10 to the power of negative 6. So make sure that in your calculation later, you must include this multiplier. So based on this small graph here, it's not complete, but it's okay because we can see that the graph touches 0. Thus, this is directly proportional graph. So let's answer that. That is should be the first question based on the graph in diagram 2.1. State the relationship between IC and IB. So IC is directly proportional to IB. So as simple as that. This should be your first mark. That never you are probably gonna make no mistake here, and hopefully that is true. Okay, number 2, determine the value of IB when IC 25.0 times 10 to the power of negative 3 amperes. Again, this is the multiplier. This is the value that we should find on the graph, and then we have to show that the value of IB. So here IC is the y-axis, so we should from y-axis find x-axis value. Remember that 25.0. 25.0 here. Okay, we see that the 25.0 here is not on the line of the straight line. So what we should do, we should extrapolate. So extrapolate. Make sure that you use ruler. You can extrapolate as long as you want. I make it until 45. Doesn't matter, but I make it until 45. And then that is the first step. The second step is to interpolate. So starting from 25 and then go down. Make sure that you use ruler and then read this value. Don't forget the multiplier here. So 0.20 times 10 to the power of negative 6 ampere. 0.20 times 10 to the negative 6 ampere. 0.20 times 10 to the negative 6 ampere. So this is the correct answer. The first mark is the extrapolation. The second mark is the interpolation. And the final mark is for 0.2 times 10 to the power negative 6, including with the correct unit and as well as the multiplier. So this is very dense things over here because you might lose marks somewhere if you don't careful. Okay, next, B1, calculate the gradient M of the graph. Show on the graph how you calculate M. So gradient, again, if you remember, we need to make 8 cm times 8 cm, the triangle, size of triangle, minimum. So my rule of thumb is we just extend until the end of the graph. Use all the graph. Because once you use that, you already over exceed the minimum requirement. That is what we needed here. So that we don't need to think hard about it. So label the coordinates. So this is, what is the final value? 0.35, so 0.4. 0.40 times 10 to the power of negative 6. Don't forget to put the multiplier, and then it is 45.0 times 10 to the negative 3. Also the multiplier. 0.4, 45. 0.4, 45. So remember that. M equal to y2 minus y1, s2 minus s1. 45.0 times 10 to the power of negative 3 minus 0. 0.4 times 10 to the negative 6 minus 0. Okay, so ampere, ampere. So we know that the unit will be unitless because the ampere will cancel out. But the multiplier somehow will not cancel out. So let's check with our calculator. Okay, so we will get 112,500. 112,500. If we want to change it into standard form, then so how much that we need? 1, 1, 1, 2, 3, 3, 4, 5. So 1.125 times 10 to the power of 5. So these both answers are correct. You can do in plain form or you can do in standard form. So the mark is the one mark for the triangle, the minimum requirements are met, then you are awarded 1 mark. The calculation here, 1 mark, and then the answer with the correct unit. In this case, it's the unitless. So make sure that you realize that. So this is important. The working that you show is very important in order for you to realize that it is unitless. Okay, so let's move on. Number 2 here, the relationship between IB and IC is given by the formula IC equal to alpha IB, where alpha is the amplification factor of the transistor. By using answer in 2B1, find the value of alpha. So alpha is actually, if you rearrange the formula, IC over IB. So let's check our gradient. So our gradient is actually IC over IB. So basically alpha is indeed the gradient itself. So we just copy back our answer. Level 112,500 or 1.125 times 10 to the power of 5. Okay. And then the question itself asks us to use the answer from previous. So we don't need to calculate more. This is just 1 mark. You just copy back once you realize that alpha is actually the gradient. So see, the emitter current I is related to the base current and collector current through the formula here. Based on the graph in diagram 2.1, determine the emitter current when the base current is given. So how you going to do that? We have to use the graph. From IB, we can find IC. And then both of this value, we will get IE. So let's find IC first. IC. So this should be simple interpolation. So remember 0.30, 10 to the power of negative 6 here. So let's interpolate that. Glad that we extrapolate it long enough, so we don't need to do extra work. And then so this is the value 35.0 with 10 to the power of negative 3. Don't forget the multiplier. 45.0. Okay. 45.0 times 10 to the power of negative 3 ampere. So now we can calculate IE. Basically, IB plus IC. IB is given 0.30 times 10 to the power of negative 6 ampere. IC is what we are looking previously. By interpolation, plugging that into your calculator. 5E negative 2. No, E negative 3. And then you will get 0.045 ampere. So this is the answer. 2 marks. So basically this is the 1 mark. And then this is the another mark with the correct unit. Step 1, precaution that should be taken to improve the accuracy of the result of this experiment. So this is the template that we should use. Make sure your eyes, such as etc. etc. But we must identify the measuring instrument first. Since both the x-axis and y-axis measure current, electric current in amperes, but the multiplier is different here. So one is negative 3, 10 to the power negative 3. One is the negative 6, 10 to the power negative 6. So the negative 3 one is the milliammeter. The negative 6 one is the microammeter. So you can choose either one. So I want to use milliammeter here. Make sure your eyes are perpendicular to the reading scale of micro, I say milli, right? So that's fine, micro as well, microammeter, to avoid parallax error. Again, you must include all the keywords to get 1 mark. So that's all for today. Hopefully you realize that how important to pay attention to details, especially in physics. You need to know how to use calculator. You need to know the multiplier, and you need to know the measuring instrument that use that specific multipliers, as well as extrapolation, interpolation, the relationship, and as well as how to determine the unit from gradient. Okay, but in this case, the unit is unitless because the ampere is cancelled out. So hopefully that you understand all of that and gain confidence in answering paper 3, and hopefully to see you